So this next lesson deals with linear functions and looking at a constant slope. So as we read through the first part, the simplest kind of function is a linear function. That's something you've been working with ever since you started with any type of function at all, any types of graphs. You started with the graph of a line, which is referred to as the linear function. That is the function of the form f of x is equal to, they tell you it's f of x is equal to ax plus b. Now that is not any different than what you are used to. That linear function you are used to is y is equal to mx plus b. It's the same thing. They're just putting it into a linear format for you. If you look on your graphing calculators, which I hate to push you too much towards that, I have in the past, but I hate to with the word that I've received from UNL about not being able to use those graphing calculators in their calculus course or anything like that, which I'm sure if they're doing it for calculus, it's dwindling down to college algebra or any of those other courses, is that when you actually look at that particular function, or if you are coming up with a best fit line on your graphing calculator, something you will notice is that it will show it as the ax plus b, and they will tell you a is this, b is this. So it actually gives you an equation. If you put in points and come up with a best fit line, it will generate that equation for you. And they use the a and the b. Now, sometimes it might be switched depending on what part of the graphing calculator you get into. So you want to make sure that you know what the variables are representing. In this case, what's a going to represent? The slope. And what's b represent? The y-intercept. Not any different than m represents the slope and b represents the y-intercept. So it tells you where a and b are constants. That means whenever you see that they are constants, that means that a particular number will show up in those positions. I am going to have a number in place of a. I will have a number in place of b. If you're talking about y equals mx plus b, you're going to have m as a slope. That'll be something rise over run. And b will be a y-intercept, some value on the y-axis, wherever it crosses the y-axis at. So you're looking at numbers put into those highlighted positions. Y and x, or f of x and x, will remain within the equation when you write it. Linear functions get their name from the fact that their graphs are lines. Thus, our study of linear functions begins with a complete discussion of lines. We assume that you have a good intuitive feeling for the concept of line from looking along a taut string at the edge of a ruler. Let us agree on one thing. 2 points determine a unique line. That's something we talked about in geometry. We've talked about that when you first started talking about lines a long time ago, maybe even in Algebra 2 when we started talking about lines. 2 points determine a unique line. In figure 16 in your book, or on the side there in your paper, there's exactly one line through points A and B. We know that. A line is straight. We define it as straight, and through 2 points there exists only one unique line. There could be multiple curves that go through there, but only one line exists between them. Now, here's some things I've had a few questions over as you've been going through, is something about slope. And that's the next thing we want to look at, is the slope of a line. So the slope of a line, consider the line in figure 16. A move from A to B produces a vertical change of 7 to 1 units. So what they've done is they've provided you with this graph, figure 16, and you get the point 47. I'm just going to try to roughly sketch this. So you get the point. Does that look like 47 to you? Up close, it looks like it to me. Does it look like 46? 47? Okay. So we have the point 47, and they also, that is point B. Point B is the point 47, and they give you point A, which is 2,1. So 2,1. Here's point A, and they're connecting them to form a line. And they say that that vertical change happens to be a change of 6. And this is the way you were used to doing it. We count slope. So we go rise over run. So I've gone up 6. That vertical change is 6. They tell you it is 7 minus 1. You take the y value, which is your vertical distance, and you subtract it from the y value of your other point. Now, if I subtract the other direction, I would have 1 minus 7, which is negative 6, instead of 7 minus 1, which is 6. That's okay. It doesn't matter which direction you go with the points as long as you subtract the horizontal direction the same way. So the next thing says that corresponding horizontal change is going to be 4 minus 2. So since I picked 7 first, I want to go with that x value first. So the horizontal change, I go from 4 and I go back 2, which is 2. That tells you that your slope is 3. Which another way to get there is I could go up 3 and over 1. I could go up 3 and over 1, and then up 3 again and over 1, and I get to that point. That's a positive slope. We'll go back and refresh our memory on those. If I happen to use the other format where I picked point 1 first, this is referring, or the y value of 1, that's referring to a minus b instead of b minus a. You will still get the same slope as long as you look at a minus b for the horizontal change as well. So the horizontal change, a is 2 and b is 4. So that change is a negative 2, and that's where you still end up with a positive 3. So if it's point A minus B or B minus A, it doesn't make a difference. You just have to make sure you're consistent with both the numerator and denominator of your slope for the y and the x changes. We know slope to be the change in y over the change in x, not to be confused with graphing a point. When you graph a point, you go on the x-axis first, then on the y-axis. But when you find slope, you do rise, which is y, over run, which is x. That's where some of you were getting confused with your graphing, I think. And you were plotting some points backwards because you were thinking of slope instead of the actual point itself. So then in the box, they just tell you, or as you go through, in general, if y changes by an amount of delta y, so the change, the triangle means delta, or it's a delta, but it means the change in y over delta x means the change in the x-axis. So we say that is the slope of a line, and they give you that information in the little box. So in the box on that page or in your notes, it'll say the change in y over the change in x is your slope, and to find it, you take one y value and subtract the other one from it, but in the same point corresponding position, you have to take the first x value and subtract the second x value from it. That will find you your slope. The next thing as we read through, it says a careful reader will ask an immediate question. Since a line has many points, does the value we get for the slope depend on which pair of points we use for A or B? No, I just showed you that we could switch them around and it wasn't going to make a difference. The similar triangles in figure 18 show us that y sub 2 prime minus y sub 1 prime is equal to y sub 2 minus y sub 1, which is, and then they have the corresponding x underneath. It does not matter. It does not matter which 2 points you pick. Since you're working with a line, it has that constant slope. It will always have a constant slope. So it does not matter. All that matters is that we subtract the coordinates in the same order in the numerator and the denominator. Questions so far? We have talked about this slope, which is what? That's a positive slope. We have talked about this slope, which is a negative slope. We have talked about this as a slope, What's that slope? A zero slope. We have those down, don't we? The figures always help. And then, of course, we have, oops, and I already started it. It's because I don't think I can, I'm just going to do it this way. I don't know if I can get my D in the right spot otherwise. And a vertical line has an undefined slope, because if you talk about the change in y, so if I were to pick 2 points on this line, this vertical line, the change in y would have a distance such as 5, but what's the distance in the horizontal direction? 0, and can you divide by 0? No. So therefore, that's why that one happens to be undefined. All right, here's some simple things that they're going to be asking you. And I should back up and have you refer to figure 19. The feature just noted that m is equal to the change in y over the change in x is constant, distinguishes lines from other curves. In fact, m is a measure of the steepness of a line. A horizontal line has a 0 slope, which we just talked about. A line that rises to the right has a positive slope. The larger this positive slope, the more steeply it rises. So a large slope, if I had a slope of 3 versus a slope of 1/3, keep in mind you can take this 3 and put it over 1. So if you have a point, you're going to go up 3 over 1, and that creates a pretty steep slope. Versus this other one, where you pick a point, and if your slope is 1/3, you go up 1 over 3, and the slope is not as steep. So the larger that coefficient of x is going to be, the steeper the slope. And then it just tells you there that if it is negative, it's going to rise to the left. And then you also have vertical lines, which have the slope of 0. Are we okay with all of that? It should be review. Should be. Hopefully it is. What they're going to ask you is find the slope from the line passing through. So I could ask you, find the slope from the line passing through the points. If I ask you to find it from the points -2, 6 and the coordinate point 4, 3. How do we find slope? Change in y over change in x. Now, for some of you, you have to visualize it. You can sit here and you can visualize it. And you can say, oh, I have this point -2, which means you go left 2, +6, which is up here in the 3rd quadrant, and I have the coordinate point +4, so you go to the right 4 and up 3, and what type of a slope should you end up with? You should end up with a negative. Some of you are going to plot the points and you're going to count rise over run. What if you don't have graph paper? Harder to count them because you don't have lines as a guideline to go by, and you get off. So the easier, or another method is change in y over the change in x, which is the first y value minus the second over the first x value minus the second. Y value. What's the first y value? 6 minus 3 over, which gives you 3 over -6, which reduces down to -1/2. So my slope is -1/2. You have a rise of 1. So if I pick a point over here, I'm going to go up 1 and back 2 so that I get that negative slope. Or from this point, I could go down 1 and to the right 2, so I still get that negative slope. Your direction is on whether you notice if it's positive or negative. You've been doing that. You should be okay with that calculation. See, I notice my computer keeps running slower and slower. Okay, I'm going to save this for right now.